Okay, continuing with sequestration of the CO2 captured. Geologic sequestration is a big target. We already saw that there is plenty of suitable sites over North America and the rest of the world to meet our sequestration demands for the next 100 years. In theory, the practical aspects obviously have to be considered more carefully. The chapter also points out that the processes involved in pumping CO2 into older oil wells and production sites of fossil fuels and coal mines and so on actually require similar skills as the people who work there. So it's possible that large scale carbon capture and sequestration could provide this well-trained labor force to accomplish the sequestration in geological sites, or geological sequestration in those sites. Okay, so this is just talking about the next figure I'm going to show is going to talk about underground storage of CO2 as a liquid can be done at depths greater than 3,000 feet, because as you go down, pressure keeps increasing and the CO2 can be put into a supercritical state where it's neither gas nor liquid. So that's kind of the state of the fossil fuel and gases that are buried down there as well. The CO2 fills in the spaces between sandstone grains. So this image here is from Reuben Johns of MIT News. Volume taken up by CO2 gas decreases as you add more pressure to it, as it happens when it is injected deep into Earth. So obviously you compress it and volume decreases. At depths greater than 800 meters, it converts into a supercritical liquid with much higher density than the original CO2 density, taking up a small amount of space in the subsurface. Okay, so this is a figure from DOE. And you can see the schematic of injecting CO2, let's say, into an old oil well, and it's going to occupy the natural spaces that are there, either naturally occurring or left behind by the extraction of oil and gas and so on. And this is showing the CO2 as a gas. As you increase pressure, its volume is going to keep decreasing. So there is the point of injection, and you can see the volume decreasing down here and eventually becoming below 800 excuse me, below 800 meters, becoming a supercritical fluid. And here is the density of CO2 shown here, going from close to 0 kilogram per meter cube near the surface to about 700 kilogram per meter cube. So massive increases in density and decreases in volume. So this is just to show you the supercritical point. So you have temperature here and you have pressure here. So there is some state where the frozen ice of CO2, for example, dry ice, is basically like a solid, and there is the liquid form with certain temperature ranges and pressure, and of course it's mostly available naturally as gas, and here is in the space of a supercritical fluid. Okay, so that's the critical point for CO2. What are the concerns? Obviously, when you pump into these open sites which have access to the surface, leakage is a serious concern. Whether they can induce earthquakes or not, this is a serious concern, especially when you have huge fault lines like the San Andreas of California. You don't want CO2 sequestration to start inducing earthquakes and do other things in addition to potentially releasing CO2. For example, pumping CO2 and water to do fracking, hydraulic fracturing to extract oil, additional oil, is inducing micro earthquakes, lots of them. we don't know whether they can get big and so on. Groundwater contamination, so this is a serious concern, but there are already regulations being put into place to make sure that groundwater remains completely separated from CO2 being sequestered. If it invades the groundwater, then obviously it's highly soluble and can acidify the water and release metals from soils and bedrock and other things that under usual circumstances with normal pH would not be released. Okay, so that's kind of the geologic sequestration of CO2. Let's move on to the California story, which continues to make bold progress in its approach in terms of even paying people who are doing direct air capture outside of California, because the idea is that whatever you are emitting in California is going to be mixed with the global distribution of CO2 anyway. How about that? Amazing thinking, right? So this is the first California hydrogen fueling station fed directly from an active industrial hydrogen pipeline. Remember, we talked about making hydrogen resource battery to deal with intermittency when we were looking at the energy pathways with fully renewable intermittent energy source versus relying on 24/7 sources of production. So hydrogen pipelines were part of the solutions to deal with intermittency, and here you have obviously fuel cells in vehicles and other needs for hydrogen pumps. So you just drive by, fill it up just like you would fill up natural gas, gasoline, and go on. So this is showing the low carbon fuel standard mechanisms in California, the LCFS it's called. So you have a standard set up here. You can be here in fuel mix A, which is lower than the standard, and you can earn actually credits, and you can sell those credits, whether you are a farmer capturing methane, you are a logistics company that's transporting but using bioenergy, and so on and so forth. Remember, we saw some of the carbon footprints of the fuels. We'll look at one more again. So if you're above the low carbon fuel standard set by California in fuel mix B, then you have to buy credits. Presumably you can do this from this company or individual or society that's earning carbon credits by using low carbon fuels, lower than what is prescribed. So I will show examples of how the low fuel standards are actually leading to increased credit earning by people and companies, and we'll look at one graph. So this is something that works. So the amazing thing there is that you can claim credit in California by doing direct air capture elsewhere. That's a pretty good way of starting business, especially if you remember we talked about the California effect before, where people are other states, especially in the US and even outside, sometimes are watching what California is doing and what works. So California is like a living laboratory from which people can learn and adopt their strategies as well.